So we were on part C with this one, so I'm going to continue with that. Let's see if I can get this whole problem done in a reasonable amount of time. So for part C, it says, when is the particle moving to the right? Well, it's moving to the right when the velocity is positive. So, and again, if I asked when it was moving to the left, it'd be when the velocity is negative. When is it at rest? When the velocity is 0. So I'm looking for when my velocity is going to be less than 0. And I think the easiest way to do this is to make what I call kind of a velocity timeline. So in our last part of the problem, we figured out that at 1, the velocity was 0. So I'm going to put a 0 there. And at 5 seconds, the velocity was also 0, or the particle was at rest. So what I'm going to do is take my velocity function, and remember we already calculated that, and I'm going to put it in its factored form, although it doesn't matter, but usually for the factored form it makes this a little bit easier to work with. And what I'm going to do is check what happens. We started at 0, so I can't go beyond there, but I'm going to check what happens in this interval. Is it positive or is it negative? So I pick a time in there, and I'm going to pick at a time of 1/2. And I'm really just looking for the sign, because I want to know when the velocity is positive. So when I put a 1/2 in there, I end up getting a negative times a negative. So this is going to be positive in here. Now I'm going to check what happens between 1 and 5 seconds. And again, I'm just going to pick another time, like maybe at time 2. Well, when I put in a 2 for t, I end up with 3 times a negative 3 times a positive. And again, it doesn't really matter the actual numbers. I'm just looking at the signs. So I end up with a negative velocity in there. And likewise, when I go past 5 seconds, you can see, I can even just go right to the right and go to 6. I'm going to have 3 times a positive in here. So this ends up being positive on to infinity. I could have picked a 20 to put in for t, and I'm going to be getting positives out of both of these products. So you can see that my velocity is positive on the time interval 0 to 1, and I leave that open because it's 0 at 1. And sometimes they might write it at t greater than or equal to 0, less than 1. You just have to be familiar with both notations. And it's also positive on 5 to infinity. So you might see that looking like t greater than 5. Either one is fine, just be able to work with both if it were a multiple choice question. So that was part C. Now I'm going to leave that timeline up there for doing part D, or that velocity line. For part D, I'm looking for when the particle's increasing in speed. And I talked a little bit before that what needs to happen is your velocity and your acceleration have to either be both positive or both negative for my speed to be increasing. So what I need to do now, I haven't dealt with my acceleration yet. I need to go get my acceleration model. Well, I'm going to go back to the velocity model so you can work with that. Let's go back to velocity, which unfactored was 3t squared minus 18t plus 15. If you go back to the problem, we did that in B and in A. So in its unfactored form, well, acceleration is the derivative of velocity, or the second derivative of position. So I just use my power rule and say it's 6t minus 18. And again, the derivative of a constant is 0. So this is my acceleration function. And I want to know when the acceleration is 0 so I can make a timeline for it. And then I can figure out where the acceleration is positive and where it's negative. So what I do is I say, well, when is my acceleration 0? And I factor this out. And it so happens that it's at 3 seconds that my acceleration is exactly 0. So what I'm going to go do here is make what I call an acceleration line. So I'm going to go back down here. Sometimes I like to put A here, just like I probably should have put V over here. And at 3, my acceleration is 0, which means to the left and to the right of 3, it's either positive or it's negative. It can't be both. And it certainly can't be 0, because this is the only place I got a 0. So, sorry, my voices going on me. So down here between 0 seconds and 3 seconds, I'm just going to plug a number in to my velocity function, and I can plug anything in there, maybe a 2. And you'll notice I'm going to get a negative, into the acceleration function. And then to the right of 3, maybe at 4, I'm going to have 6 times 4 minus 18, which is going to be positive. So my acceleration is positive from 3 to infinity and negative from 0 to 3. Well, I'm looking for when the particle's increasing in speed. So now with my black pen, I kind of have to analyze both what happened in part C and what happened in part D, because I have to find where they're both positive and or they're both negative. Well, let's take a look at where they're both positive first. All right? So the velocity is positive everywhere greater, look here in black, than 5. Acceleration is positive greater than 3. Well, where do both happen? And I would answer that question with greater than, I'm going to extend this so I can get a little room, anywhere greater than 5. Both of them are positive. All right? Excuse me. Next up, I want to know where both are negative. Well, acceleration's negative all the way from 0 to 3. But velocity is only negative from 1 to 5. So I'm kind of looking at where do those two cross? Where are they both going to be negative? I'm so sorry about my cough. So it's going to happen from 1 to 5 here and only from 0 to 3 here. So I'm looking at where there's a crossover there, and that would be between 1 and 3 is where they both are. So I'd say my speed is increasing when it's greater than 5 because both are positive there, both acceleration and velocity, and between 1 and 3 because that's where both are negative. All right, the last question for this one is a tricky one. I think I'm ready to erase. I'm wondering, I think I'm going to tackle part E when I can actually give you some notes. So what I want to do, what in the world just happened? Excuse me, I don't know what just happened with this thing. So it's giving me all my pages all laid out in a goofy form. So what I'd like to do here, I can get rid of that. Oh, dang it. Unfortunately for you, or fortunately for you, I think I'm going to have to quit here. So I'm going to give you, I don't know what I clicked on there to do this. So what I'm going to do is just get some blank paper here so I can tell you what you need to do. So I'm going to go into this real quick. Having system failure. Anyway, so we're going to get a worksheet. Maybe my sub can pass the worksheet out while I'm loading this. And you've got a pretty good chunk of time, probably about 25 minutes to work. So I'm just waiting to get some paper here. Come on, there we go. So I'm going to get some blank paper while you're getting that worksheet. Hopefully he or she is passing that out for me. And on the worksheet, I'll tell you which ones you have to do. Let me find mine. These are the ones you get to skip. So cross out 3, and my son might want to pause this video just while you're getting your worksheets passed back. Cross out 4, cross out 7. Those are ones like we did yesterday, and I think 1, 2, 5, and 6 will cover that just fine. So when you're doing 1, 2, 5, and 6, that's your product and quotient rule from yesterday. Number 8, we're going to wait on. So don't cross it off, but don't try it yet. I need to give you a little more notes about what a normal line is. So we're going to wait on that. The other one you're going to cross off will be 13 can go completely, 14 can go completely, and 17 can go completely. So the rest of them are all due. They're due on Thursday, but right before you turn them in on Thursday, I'm going to go over number 8. What I'd like you to do right now is take out a blank sheet of paper, because these are going to have to go on a blank sheet of paper. There's not enough room. We're going to tackle number 10 together. Maybe not the whole thing, but we're going to do a part of it. So for number 10, on your blank sheet of paper, we've got our position function is given by t cubed minus 6t squared, and they didn't give any units, but I suppose we could assume that it's let's assume it's meters and seconds. And for part A, let's go do it together. It says you are to make a table showing position, velocity, speed, and acceleration. So I'm going to make a table right here, and it's all dependent upon time. And I'm going to do position, velocity, and if I don't finish this, you'll have to finish it. I'm not going to go into another video. And it says speed. So what should we call that? Let's just call it speed. And acceleration, A of t. All right? And it says to do that for times 1, 2, 3, 4, and 5. So what we need to do here, we've got our model for position. So what's easiest is to enter this under your y equals button and go look at the table, because putting those all in one by one isn't very fun to do. So again, just go to your graphing calculator. I can bring mine up really quick here maybe. Go to your y equals button and let's enter that. X to the third is our function, and minus 6 x squared. So let's go look at the table, and you should probably already have it set to ask. So let's go to the table, and we are supposed to do it at 1. Oops. Why it's not entering in there. I think it's good. And a 2. I already did it actually, 1, 2. I guess I don't have to enter them. It's all in there. So let's go log that in on our chart. Let's go do it at 1, 2, 3, 4, and 5. And it was a negative 5, negative 16. It also gave me the 0 on there, which I don't need. Negative 27, negative 32, and negative 25. So that's your position function. Velocity, in order for you to get that, you need to give me the velocity model. So remember, your velocity is the first derivative of position. So it'd be 3t squared, and then minus 12t. So again, you could go to your y equals button and enter this, and then go look at the table. And I'll give you those. I know you know how to work your calculator. So I'm going to go put all the velocities in there. And we get a negative 15. If I were now to ask you when was the particle at rest, you would say at 4 seconds. When was the particle moving to the left in this area and to the right in here? So you can answer those questions. Speed is the absolute value of velocity, so this is 9 pi feet per second, 12, 9, 0, 15. All right? My acceleration is the derivative of velocity. So my A of t is going to be 6t minus 12. And again, you might want to just go enter that under your y equals button. And when you do, or you can do this one by hand, I mean, you can see that when you put in a 2, it's going to pop out a 0. So either way, whatever's quickest for you, it doesn't matter to me. So the question is, make a table, which I did, and it says at each of these times specify the direction of motion and whether the particle is speeding up or slowing down. So let's go take a look at it. This is going to give me the direction of the motion. So for each of these, it's going left or down, actually in this case, because it didn't say along a line. That's actually a cubic function. So it's going down. The direction is down. The direction's down again. When the velocity is 0, I guess we'd say it's at rest. And then at the end, it's going up. So that is my direction, and now I'm supposed to say whether it's speeding up, slowing down, or neither. And remember, we're speeding up when both the acceleration and the velocity have the same sign. So maybe I'll extend this into a little nicer table here, and I need to know if it's speeding up, slowing down, or neither. So I'm going to be analyzing these two columns right here. And right here I've got a negative velocity and a negative acceleration, which means I'm speeding up. Next one, I have no acceleration right here. So this one's actually a neither. Really what that means is when there's 0 acceleration but you have velocity, it means it's holding constant. Like when you're in your car and you're going 15 miles per hour for and not increasing your speed at all. So it's just remaining a constant acceleration there, and velocity, I mean. The next one